Okay, so we finished or just started on or almost done with graphing phase shifts. And so phase shifts were just transformations of graphs of our trigonometric functions. And the phase shift is how much we were shifting it horizontally. And so we were looking at functions in the form of y is equal to a sine parentheses bx plus c, and then end the parentheses, and then plus a d. And so the absolute value, recall, was equal to our amplitude. And this was also for sine, so let's just put sine or cosine also. So these hold for both of these. We can figure out what our period is. I told you guys to sandwich it in between 0 and 2 pi and solve for x. So if you do this, so if you have bx plus c, right, and you're looking at this between 0 and 2 pi, and we solve for x, we can get this formula. So let's subtract c on both sides. And then let's divide through by b. And so we get negative c over b is less than or equal to x, which is less than or equal to 2 pi minus c. And so that length well, that was from our start value, 2 pi minus c. I'm sorry, our end value, minus our start value, which was negative c over b. So this is 2 minus c plus c over b. So I forgot to, when we were dividing by b, to divide the 2 pi minus c divided by b. Okay, so doing that, we can break this up as to two separate fractions, or this first term. And so this is 2 pi over b minus c over b plus c over b. But notice the negative c over b plus the c over b, those are the same, so those cancel. And so the length of our period is just 2 pi over b. The phase shift is how much you're shifting either left or right. And so notice that when we had sandwiched it right here and we got x by itself, notice this is our first space that we're starting at is negative c over b. That's the start of one period. And so normally we started at 0. So basically you're taking your 0 value and you're shifting it over to the left, negative c over b. And so the phase shift is, I'm going to say the absolute value of c over b. If c over b is greater than 0, then it shifts the graph to the, well, this is, c over b is greater than 0, it's going to shift it to the right. Negative c over b. Oh, and c over b is less than 0. Shifts the graph to the left. Okay, so phase shift is just how much you're shifting it horizontally. And then the value of d, this is how much we shift vertically.
Wait, which part was how much you shift horizontally? I missed that part.
It's C over B. So it's
Thank you.
increment, yeah. And so whatever constant we're adding to the coefficient of x, take that and divide by b in the opposite sign. But really, like if when we're graphing these, if we just set it up like we were doing when it was just our sinusoidal curve of bx, instead of adding that constant in there, like we sandwiched it between 0 and 2 pi, you can always just figure this out without the formulas. Okay. So let's look at an example. And I'm not in the right section. So let's graph the following. What if it was y is equal to -2 cosine of 2x plus pi halves and let's do -4. Okay, so I like to figure out what my amplitude is. I like to figure out what the max and the min values are going to be. So your y values, where the highest and lowest y values your graph is going to hit. And then I also like to know what the period is, a start value, end value, quarter, half, and 3/4 values of a period. And we can do that by figuring out the argument sandwiched between 0 and 2 pi. And so our amplitude is always the absolute value of the coefficient in front of sine or cosine. And so this gives us back 2. So normally, if I was just graphing y equals negative cosine of that parentheses, 2x plus pi halves, then I would have a max value at 2 and a min value at -2. But this -4, this shifts my graph down 4 units, so that affects my max and min. So my max value, well, it was originally at 2, but if I shift that y value of 2 down 4 units, it's now going to hit at -2. And my min value, well, before it was hitting at -2 for this graph, but I'm shifting that y value down 4 units, so it's now hitting at -6. And so now let's look at the period and phase shift. So we're going to sandwich this 2x plus pi halves in between 0 and 2 pi. And now we're getting x by itself. And so let's subtract pi halves on all sides. So we get negative pi halves is less than or equal to 2x. Which is less than or equal to, I'm going to get a common denominator so I can combine this as one value. So this is really a 4 pi halves minus a 1 pi halves is a 3 pi halves. So we need to get rid of the 2 in front of the x. We can think of it as dividing all terms by 2 or multiplying all terms by a half. So if we multiply everything through by a half, we get 1/2 times negative pi halves. Well, that gives us a negative pi fourths. This is less than or equal to x, because 1/2 times 2x is x, is less than or equal to 3 pi fourths. So our phase shift is negative pi fourths, or we can say it's pi fourths to the left. Or shifts. So what is shift? Y equals negative 2 sine of x. Actually, 2. Pi fourths to left.
If we're dividing it by 2, why did we do 1/2? I'm just confused on that.
Oh, because another way of thinking of dividing by 2 is multiplying by a half.
Okay.
And so I didn't want to deal with my complex fraction. So I didn't want to have to deal with 3 pi halves divided by 2.
Okay, got it. Makes sense.
So if there's a fraction in front of the variable that you're trying to solve for, and that was the last step, multiply, another way to think of it is always multiply by the reciprocal of that number, because the reciprocal of a number times that number is always 1. Okay, and so we now know what our start value is. And actually, let's find out what the period is. So the period is always the end value of 1 period, and we just found that it was 3 pi fourths, minus the start value of 1 period, which we just found was negative pi fourths. So 3 pi fourths minus a negative, so 3 pi fourths plus pi fourths is 4 pi fourths, but that reduces to pi. So your book does a little differently. They figure out that your length of your period is pi. They subdivide that into 4 separate intervals. So they divide your period into 4, and then they add that from your start value. That would give you your quarter value. They add that to your quarter value. That gives you your halfway point. They add that to the halfway point, gives you a 3/4 point, etc. So you can do it that way, or you can do it how we've been doing it, which is we know we're starting at negative pi fourths. We know that we're ending at 3 pi fourths. So halfway point, again, is if we add the start plus the end. Oops, that should be a pi fourths. And divide by 2, or same thing as multiplying by a half. So negative pi fourths plus 3 pi fourths is 2 pi fourths, and 2 pi fourths times a half. So that gives me 1 pi fourths. Quarter-way point. Well, if you add the start point and the halfway point and divide by 2.
I can't hear you.
Can't hear me at all? Let's see.
I can hear you.
You can hear me?
Yeah, I think everyone else could hear you except for her.
Oops.
Yeah, I can hear you too.
Okay, so something's wrong with your the sound somehow. I don't know who said that. So add the negative pi force plus the pi force. Well, that's just 0. Well, divide 0 by 2, you still get 0, or 0 times 1/2. So our quarter point is 0. And now we need to find our 3/4 value or point. It's not really a point because it's not really the x and y values. 3/4 value. So pi force plus 3 pi force. And then divide that by 2, or same thing as multiplying by 1/2. So that gets 4. I'm always thinking about the 2 I'm dividing by and writing it. So this gives me 4 pi force times 1/2. I'm gonna reduce it a little bit, but I like that my denominators are the same. To me, that makes a little bit more sense. And so let's take the 2 goes into 4 2 times. So this gives me 2 pi force. So 2 pi force is our 3/4 point. Okay, so we're pretty much ready now to put it all together. So let's graph or plot the x values.
So is our period 3 pi force or pi over 4?
It is 3 pi force. Oh wait, our period?
Yes.
Our period is just pi, wasn't it?
Yeah.
Yeah, period is
Okay.
pi.
But our start value is negative pi force, and our end value, that was the 3 pi force. Okay, so negative pi force. And I might want to shift my x-axis up. Well, I guess it doesn't matter. I'll just shift down. We have 0. We have pi force. We have 2 pi force, or you can write it as pi halves if you want. And we have 3 pi force. We talked about our max and our min. The max value that we got on our graph was -2. And the min value that we got on our graph, I believe, was -6. Yeah. Okay, so -2, 3, 4, 5, 6. And so that midway line, well, if we shifted everything down 4, so we're going to treat it like it was our x-axis. So our midway line, and we kind of put a dotted line there just to help us graph, to use it, is at y equals -4. We are a cosine graph, so we don't start normally on the x-axis or the midway line. We start either at the max or the min, depending on if the value in front is positive or negative. And we learned-
Professor,
Yes.
for our max, we got -2. How are we gonna so is that just our max, -2, or we change it to positive?
Right, so we're not going to, this graph won't even go above the x-axis.
Okay.
And our function, right, it had a negative in front of the cosine. And so that instead of starting at our max value, we're going to start at our min value. And so our min value, we said, was -6. So we're going to start down here at negative pi force, -6. And then at the quarter value, which happens to be when x is 0, we're going to hit the midway line. So that is at -4. At pi force, we're going to hit the max, which is -2 for our graph. At 2 pi force, you're going to come back down and hit the midway line. And at 3 pi force, you're going to hit your minimum. And so here's what one period of the graph would look like. And then we can extend it both directions.
Could you repeat one more time why you started on that point you started at?
Yeah. So there's a couple reasons why we started down here. When it's a cosine, I know that it's either going to start at the max or the min. It depends on if the coefficient is a positive in front of the cosine or negative. If it's a negative number, then it's a reflection usually across that x-axis, in this case, midway line. And so instead of starting at the max, I'm going to start down at the min value because it's cosine. The reason why we're down here at the -6 instead of down at -2 is because of the -4 outside. We were subtracting 4 off of our function, cosine function. And so that shifts the whole graph down 4 units. And so where we used to be, you know, the midway line used to be our x-axis, that now shift down 4 units. And so we kind of treat this like it was our x-axis to get the graph. Does that help kind of recap?
Professor,
Yes.
I understand that, but like, why did you start at -pi4, -6? Is
Okay.
that just where it starts?
Yeah, so I had to start at, because of the argument had something, a constant added to that coefficient with the x in it. Where did our graph go? That tells me that right here, this tells me the shift in the graph. There's going to be some shift horizontal.
Oh yeah, I forgot about that. Okay, thanks.
And that's why. So there's a couple ways to do it, like we kind of did it. I think that's the easiest way. We could factor out a 2 here and then see whatever is left in here. It's the opposite. But I tend to like to do it this way just because it's helpful for graphing.
Mm-hmm.
Can't you just do C over B for phase shift?
Yep. Yep. So you can do it that way too. You have to be careful with the sign though, since this is plus inside, it's actually the opposite of what you think.
Yeah, plus is minus, minus is plus, yeah.
Yeah.
So excuse me, Professor.
Yes.
Regarding the phase shift formula, did you put an absolute value bar?
I did, just because, and I'm not sure if they did that or not in your book, but I just tell the phase shift, and I tend to say is it left or right.
But wouldn't that mean it's always positive?
It would mean that it's always positive, and so we have to be careful. Let's see. What did I say here? Sorry. Yeah. They say it's just C over B, and then I believe they say it depends on the sign. So I'm not sure if I'm mathematically correct on saying this is an absolute value or if that's just how I kind of just like it. And this is a different textbook. So I'll go back and look at that. Maybe during break if I remember phase shift. And clarify that.
I would think that it's not an absolute value because it can be negative, right? And if it's negative, it goes to the right.
Yeah, if it's negative, it goes, well, that's where it's kind of iffy. If that's inside the parentheses of the argument, then it goes to the right if it's negative. If it's positive, it's gonna go to the left. But see, notice how when I was solving it though, where was it? I had negative CB here, which made sense that it went to the left because of the minus sign. You're moving your X value over negative, but it was positive in there. And so that's why I put the absolute value there.
Does it usually turn out that it is the opposite?
Yes, if you're looking at it, it is. Well, not necessarily. Yeah. It has to do with the shifting, and it depends on how we're looking at it, if it's outside of the argument or inside the argument. That's why I kind of just like to do it this way. So let me get back to that. I don't want to get stuck there. But basically, if you solve it like we did, then that will tell you where it starts. Where are we at? So let's look at another example real quick. And let's say you were given information and it's asking you to find the equation. So find the equation. The sine function. That has an amplitude of 2, a period of pi, and a phase shift of -2.
Professor?
Yeah.
Can we also do one where like we have to like find the equation like looking at the graph?
Yeah, this one I don't see any of those types of problems in here.
Oh, okay.
We did have one like that. We did though, from
Yeah, I remember.
7-6.
Okay.
So finding the equation. So we know that it's in this form. Y is equal to a sine some bx plus c plus d outside that parentheses. Phase shift is -2. I noticed that it doesn't tell me anything about a vertical shift. So there's no vertical shift. So this is going to equal 0. Our A value, well, it told us that the amplitude was 2, and it didn't tell me anything about the direction of the graph being different. So we're going to assume it's +2. Our phase shift and our period. So our period, the formula, if this is where the formulas come actually in helpful. So the phase shift, I'm sorry, I guess I said phase shift now. So the phase shift was C divided by B. And I know that this is equal to -2. My period, the formula is 2 pi divided by B. But we're given that this was equal to pi. So this is equal to pi. So I got 2 separate equations. One equation I have one unknown, the other I have 2 unknowns. I could figure out what B is for the period from the period equation, and then I could plug that back into the phase shift equation to figure out what C is. So we can isolate B by multiplying both sides by B. So we get 2 pi equals pi B, or B pi. Divide by pi. So we get our B value in here is 2. And then let's go back up here and plug in 2 for B. And so if we do that, we get C all over 2 equals -2. Multiply both sides by 2 to get rid of the 2 underneath the C. We get C is equal to -4. So if we plug that back into our equation, we have y is equal to our a value, which we said was 2, sine of b, which we saw was 2, plus c, but plus a -4 is -4. And then we didn't have any vertical shifts, so we don't have to really add +0 there. And so we now have an equation that satisfies that information.
Professor, I had a quick question.
Yes.
How did you determine that it was a sine equation, not a cosine equation?
Just because it was given in the problem, they said,
Was it?
yeah, it said find the sine function.
Oh, okay.
Yeah, so if that it didn't give me that, that would be a problem. And so with the graph, sometimes when they're giving you the picture of the graph, if they don't tell you either sine or cosine, you could write them either way. They look a little different, but they would give you the same graph. Okay, so getting into inverse functions. This is the start of 8.1. So inverse trig functions.
Everything we just did was 7.8, right?
Right.
Okay.
Okay, so recall. In order for a function to have an inverse, it has to be a one-to-one function. Okay, so one-to-one function, recall, that had to pass the horizontal line test. In order to be a function, it had to pass, the graph had to pass the vertical line test. Wherever you drew a vertical line, it could only intersect once. To be a one-to-one function, it also has to pass the horizontal line test. So wherever you draw a horizontal line, it can only pass that function once, anywhere on the graph. Well, that doesn't happen with sine or cosine, right? Or any of our trig functions. If you draw a horizontal line through our picture, it's going to intersect in multiple places an infinite number of times. And so we can make our functions one-to-one by limiting our domain. Okay. But trig functions are not one-to-one. And shorthand for one-to-one is 1-1.
What is that word before trig?
Before, sorry, before what?
Trig functions? You
Oh,
just read it?
inverse, just inverse.
Oh, okay. No, the one at the bottom.
Oops, sorry. Oh,
Says-
but
Oh.
trig functions, yeah, are not one-to-one. unless we limit the domain. Okay, so let's just look real quick. Cosine's a little easier. Cosine, we started at 1, normal function. And then we got down to pi halves. Then we got to pi, we hit -1. 3 pi halves, we're back up at 0. And then 2 pi. Okay, so our function looks similar to this. And so if we draw, like I said, anywhere on this graph and we can draw a horizontal line and it crosses more than once, it's not 1-to-1. But if we limit that domain, and let's say we cut it off where x is 0, and cut it off here at pi. So notice we're hitting all of our x values, our y values in between 0 and pi. We're hitting all the positive values and we're hitting all the negative values. And so let's limit for cosine. Limit the domain between 0 and pi. And so our range are all the y values you're hitting, are between -1 and 1. So now that we've limited the domain, it's a 1-to-1 function, which means that it has to have an inverse. And so recall to find your inverse function, that's where you swapped your x and your y values. So if we had f of x is equal to cosine of x, this is where we said, oh, this is the same thing as y is cosine of x. Swap x and y and solve for y. That would give us our inverse function. And so if I did this, this is x is equal to cosine of y. But we don't know how to do that. And basically, if you use the fact that a function and the inverse function, the composition of the two is equal to that value. So I'm using the fact that, so I'm going to take the cosine inverse of both sides. So cosine inverse of x, this is equal to y. And so f inverse of x is equal to, is written this way. Okay, that -1 that kind of looks like an exponent is not really an exponent, and that is not the same as 1 over cosine of x. So just make sure that you don't do this. Another thing to remember is that information about a function and its inverse. Well, when we were solving for the inverse function, we were swapping our x and y values. So the domain of our one function is the range of the inverse function. And the range of one function is the domain of the inverse of that function. And so here we can say that our domain is between -1 and 1. And our range has to be between 0 and pi. So actually we're thinking backwards here. And so let's look at an example. Let's say it wanted us to find cosine inverse of root 3 over 2. So we're trying to find what angle gives us back root 3 over 2 for cosine, and it has to be between 0 and pi. Okay, so you got to think backwards. What angle gives you back root 3 over 2?
Excuse me, I had a question.
Mm-hmm.
So is this is the inverse of cosine different from secant?
Yes. Yes.
Cosine 60.
Okay, so cosine of 60 is actually 1/2. So it would have to be cosine of
30.
30. And because we're doing between 0 and pi, we're not going to think of it as degrees. So which one is 30 degrees? Which is what radian?
Pi over 6.
Yeah. So why would this answer, why would have to equal pi 6? This is contained in that interval between 0 and pi. There's another angle that gives us root 3 over 2. That would be 11 pi 6. But 11 pi 6, quadrant 4, cosine's positive, is not in that interval. It's past 0. It's past pi. So we're only looking at the 1 in here. So thinking kind of backwards. What about, I'm just kind of pulling them out of my head. Cosine inverse of negative 1/2. So find the exact value of each expression is what this is saying. So you're trying to think to yourself, cosine of what value is equal to negative 1/2, where that value has to fall between 0 and pi. So first thing I kind of think about, I ignore my negative and I think to myself, okay, cosine of what value is 1/2?
Cosine 60.
Right, so 60 degrees, but we're in terms of radians, so it is,
Pi over 3.
yeah. So we know cosine of pi thirds but we want it to be negative. And so we have to think about it 0 and pi, if I'm thinking on the unit circle that's on in quadrant 2. So I know that my angle has to be, think of it as the angle in quadrant 2 to make negative for cosine. Between 0 and 2 pi, or 0 and pi. So we can get that value, right? Our reference angle then is pi thirds. And so if we look at pi minus pi thirds, because you're always going from the x-axis, that would get me into the second quadrant. So common denominator is 3. So 3 pi thirds minus 1 pi third gives us 2 pi thirds. So our angle is equal to, so cosine inverse of -1/2 is equal to 2 pi thirds. Okay, so kind of the same reasoning behind sine, except sine we have to limit the domain a little differently for the inverse function.
Excuse me, Professor.
Yeah.
So if it wasn't a negative function, would we add it instead to get to the first
No,
quadrant?
if it had been cosine positive 1/2, cosine inverse,
Mhm.
then we would have been between 0 and pi halves, because that is in first quadrant. And so we would have just had positive pi thirds as our
Okay.
answer. So let's look at the graph of sine real quick. So this one was the one that started at the origin. And then once we hit pi halves, we went up and we hit the max of 1. At pi, we came back and hit the origin. At 3 pi halves, we hit -1. At negative pi halves, we hit -1. Negative pi back up at the origin. Not the origin, the x-axis. Okay. So notice again, this does not cross, it's not 1-to-1, doesn't pass the horizontal line test. If we sandwiched it in like we did before, for cosine, which was 0 and pi, notice it still is not 1-to-1. If I cross here, it's going to cross multiple times. And so we don't want to limit it like we did for cosine. We need to make it so that it's getting all pieces, positive and negative. And so instead, you are going to sandwich it in between negative pi halves and pi halves. So if we sandwich it in between these two values, x values, notice that it's now a 1-to-1 function. And so y equals sine of x. We're going to limit the domain. To be between negative pi halves, comma pi halves. Our range, we're hitting all the y values like we would for our sine, are between -1 and including to 1 and including. So we can write our inverse function . It's written as sine with a little -1, looks like an exponent, but not. Like this. Domain and range are swapped for functions and its inverse. So in this case, our range, our domain is between -1 and 1, and our range is between negative pi halves and pi halves. So if you're given, how about sine inverse of √2/2? So you have to think backwards, what sine of what angle or what measure would give us root 2 over 2.
Pi over 4.
Yep, so pi fourths. So this would equal pi fourths, and it's positive, so it's pi fourths. Where if this had said, find sine inverse of negative root 2 over 2, well, it has to be giving me a negative number, and it has to be, think of it, negative pi halves and pi halves. So I'm thinking in the unit circle, that's quadrant 4 and quadrant 1. And I have to think about when sine is negative. Well, that's going to be in the quadrant 4 piece. And so I can get down to that piece by, and they look at it as going, the negative angle is clockwise. So we can think of it as our reference angle is pi fourths. So this is going to be negative pi fourths to give us negative root 2 over 2. So it's not 7 pi fourths, which is a coterminal angle to that, which would give us the same terminal side, because that's not contained in this interval that we narrowed it down to, negative pi halves and pi halves. Or even the third quadrant sign is negative. So if I think of pi plus pi fourths, that's 5 fourths. Okay. Okay. So maybe let's do a couple more. How about cosine inverse of cosine of negative 5 pi thirds? Okay, so a lot of times when we take a function and it's inverse, they cancel each other out and they just give us that angle. And we're going to use that later on in this chapter to solve for variables. We're going to take inverses of our trig on both sides so that we can get rid of the trig function and get what our angle is. Here, though, we need to be careful because cosine inverse of negative pi thirds is not going to work because it's not in our domain. So first thing that you want to look at is the inside. Cosine of negative 5 pi thirds. Well, let's just think about cosine of negative 5 pi thirds for a second. So some of you on the exam, and I'm still not done, I got 4 more exams graded yesterday, but some of you on the exam, you guys were just giving me answers for some of these and you were wrong, and I couldn't give you partial credit because you didn't show work. So if you showed work here, like you were going negative 5 pi thirds, so this is, let's see. It would be right in here. So clockwise, and this is negative 5 pi thirds. And so I know if I add another pi thirds to 5 pi thirds, that's 6 pi thirds, which is 2 pi. So my reference angle reference angles are always positive and I'm forming with the x-axis. And so reference angle is pi thirds. And it's in the first quadrant, cosine is positive. So this is equal to positive of cosine of 5 pi thirds. I'm not sorry. It is that too because it's an even function, but I want to just say pi thirds. So cosine of pi thirds, cosine of 60 degrees is 1/2. Okay, so let's replace this. So we have cosine inverse of cosine of -5 pi thirds, which is positive 1/2. And now you're thinking backwards. Cosine of what angle gives us back 1/2? But that angle has to be between 0 and pi. Well, we know cosine of 60, which is pi thirds. And pi thirds is between 0 and pi, so this is equal to pi thirds. Okay, so let's take a break. And then we can talk about some of the other trig functions and what their limited domain is to make them one-to-one. So we're looking now at tangent and determining how we need to limit the domain to make it a one-to-one function so that it has an inverse function. And so if you recall, y equals tangent of x. This had asymptotes and those occurred at the values which made our denominator equals 0. Remember, tangent is sine over cosine, so sine of x over cosine of x. Cosine of x is 0 at -pi12. And positive pi12. I had a point at 0, 0. So when x is 0, we have sine of 0, 0 over cosine of 0, 1. At -pi4, we have sine of -pi4 is -√2/2. Cosine of -pi4 is positive √2/2. So this would give us -1. And then at pi4, we get positive 1. So we saw that the period was pi and it started to repeat itself. Well, if it starts to repeat itself, it's not going to pass that horizontal line test. And so for tangent, notice if we just limit it between -pi12 and pi12, then we're good. And so we're going to have the domain, but we can't include -pi12 because it's undefined. So we can put a parentheses there, comma pi12. And the range, well, between -pi12 and pi12, notice the y values you're hitting are all the y values. So all real numbers are -infinity to infinity. So if we're looking at the inverse function, we're going to write it as tangent. It looks like a -1 exponent, but not, of x. Domain and range swap. So our domain now are any real numbers. And our range has to be between -pi12 and pi12, not including. So if you're looking at tangent inverse of -√3/3. So what value of theta? So first we're going to think what value of theta would give us back positive root 3 over 3. And so that one has multiple 3's in it. And so that was the one that we said, how I remember it is 30 degrees because it has the 3 in it. But we're in terms of radians. So 30 degrees is pi 6. So theta equals pi 6. Works. This we are going to consider is our reference angle. So what value we need to think now gives us back negative root 3 over 3. And so it has to be between negative pi halves and pi halves. Well, positive pi 6 is positive root 3 over 3. Then if we go clockwise down in the fourth quadrant, that would give us a negative. And so tangent inverse of negative root 3 over 3 would have to equal negative pi 6. Before I do that, so by definition, in order to be an inverse function, basically if you take the composition of those two functions, and it doesn't matter order, which composition of functions normally matter, order matters. But when you take the composition of a function and its inverse, you always get back x. But we have to be careful here, and that was one of the problems we did. I had said we have to be careful because of the new domain or range that we're following in. And so if you're given that, and this is for sine, f inverse of f of x, if this was equal to sine inverse of sine of x, well, think about this. So x term, we have to look at sine of x. Sine of x, x would have to be between negative pi halves and pi halves. So in this case, we have to say negative pi halves is less than or equal to x is less than or equal to pi halves. Where if we looked at it in the opposite direction, f of f inverse of x, so sine of sine inverse of x. Okay, so the inner function, sine inverse of x, our x values are between negative 1 and 1. So negative 1 is less than or equal to x is less than or equal to 1. So same kind of idea with cosine. If it was f inverse of f of x, where we had cosine inverse of cosine of x. So the inner function is cosine of x, where we're going to plug in our value of x first. That has to be between, we limited x between 0 and pi to be 1 to 1. Where if it was f of f inverse of x, which is cosine of cosine inverse of x, well, the domain of cosine inverse of x is between negative 1 and 1. For tangent, we can do the same kind of idea. So if we have f inverse of f of x is equal to tan inverse of tan x. So x, we limited for tangent to have an inverse between negative pi halves and pi halves, but not including, because those are undefined there. And then f of f inverse of x, which is equal to tan of tangent inverse of x. Our x values, well, x values for tangent was negative infinity to infinity for the range, which is the domain of our inverse function. So x values can be anything, any real number.
Can you go back up to the sine function, please?
Yes. Go.
Okay, thank you.
Yep. Okay, so just have to be careful when we're taking the trig function and its inverse, if we're in the domain or not. So for instance, if we had tangent inverse of tangent of negative 2 pi thirds. I can't just say that this is negative 2 pi thirds because that is not in my range for the inverse function. So if you just first work it, so tangent of negative 2 pi thirds, we're okay because our domain here, let's look at this. So let's look at negative 2 pi thirds. So if I do this, this is going to get me right here. So our reference angle well, we have to figure out what is that angle in here that gets us up to the positive x-axis.
Pi thirds?
Yep, so this is a measure of pi thirds and it's always positive. And so we can say, well, that's the same thing then as tangent inverse. They're going to give us the same value of tangent of pi thirds, except is that tangent going to be positive or negative down there in the third quadrant? Because tangent of pi thirds is positive. The tangent of pi thirds in the fourth quadrant, is that going to be positive or negative? Tangent's negative in quadrant 3. Actually, sorry, no, it's not. Tangent is positive. Okay, so we're okay. So tangent of pi thirds, tangent of 60 degrees, that's the root 3. And so now we have to think about what angle gives us back root 3, and it has to be between negative pi halves and pi halves. Well, I know it's between 0 and pi halves because it's a positive number, and that would be just pi thirds. So sine inverse of negative 1.5. sine inverse. The domain of sine inverse of theta is between -1 and 1. So if you plug that in the calculator, you're going to get an error. This is impossible. So this is undefined. It's not possible. Undefined. Okay, so a couple of the homework problems ask you, given the trigonometric function, to find the inverse. So if you're given that, so find f inverse of x, then f of x is equal to, let's say 3 sine of 2x. And you're given that x is between -pi4 and including pi4. Okay, so to find inverse functions, if it's in function notation, I first rewrite it as y equals. So we have y is equal to 3 sine of 2x. You swap your x and y values, and then you solve for y. So this is now x is equal to 3 sine of 2y. So now we want to find y. So we need to get that term, we need to get y all by itself. So first thing we can do is we can get rid of the 3 in front of our sine function. And we can do that by dividing everything through by 3. So we have x over 3 is equal to sine of 2y. I can't tell whose mic is on.
Nayeli. Nayeli, your mic is on.
Sorry. There we go. I got it. Thank you. Okay. So we're almost there. Get y by itself. So we can, to undo the sign, we can take the sine inverse of both sides. And so let's take the sine inverse of both sides. So we have sine inverse of this x over 3 is equal to sine inverse of the sine of 2y. Okay, so sine of sine inverse or sine inverse of sine, that just gets rid of each other and gives you the argument. And so this one side, we get back just 2y. This other side, nothing cancels. It's just sine inverse of x over 3. So get x by or y by itself. We can divide both sides by 2. So we get y is equal to sine inverse of x over 3 divided by 2, or f inverse of x. You can keep it like that, or we can pull the 1/2 out front if you want. So 1/2 sine inverse of x over 3. Okay. And so we could test it. We can show that that is the inverse function by taking the composition of both sides. So let's just show it. So we want to show that if we plug in f inverse for x, wherever we see an x in our original function, then we should get back x. I'm okay with you showing one direction. You could show it the other direction where you plug in the original function, wherever you see an x and f of x. So if I look at my original function and I'm going to go back in, let's put a parentheses wherever we see x in the original function. So our original function was we're going to replace that with this 1/2 sine of x over 3. Okay, so original function, that was 3. Oops. Sine of 2, and then there's an x. So that's where we're going to replace this x with this 1/2 sine of x over 3. Okay, so notice here that the 2's inside my argument, this 2 times the 1/2, those 2's cancel. So we're technically left with 3 sine of the inside, which is sine inverse. Oops, that was a sine inverse. Of sine inverse of x over 3. So sine and sine inverse, sine of sine inverse, that cancels each other out, leaving us with an argument. So this is 3 times just x over 3. 3's cancel, leaving you with x. Okay, so we showed that what we did, what we found, does work. It is the inverse by definition. So you're given equations and you're asked to find the exact value. So find the exact value of the following. So let's say you had 2 cosine inverse of x equals pi. Okay, so basically we want to isolate x. So we can first isolate our trigonometric function by dividing both sides by 2. So we have cosine inverse of x equals pi halves. We can get rid of the cosine inverse by taking the cosine of both sides.
What happened to the denominator on 2 cosine inverse x?
Oh, I was getting rid of it by dividing all terms by 2. So I divided both sides of my equation by 2.
Oh, I see what you did. Okay, yeah,
Originally
sorry.
it was equal to pi. And so now we can take the cosine of both sides. So if we took cosine, so cosine of cosine inverse. Okay, we're just going to keep it the same color because it doesn't want to cooperate. So cosine of cosine inverse, they cancel each other out, leaving you with just x equals cosine of pi halves, which is one that we should know. That gets me up to the y-axis. Cosine is my x value of my unit circle, so that would be 0. So x is equal to 0. So same kind of idea. Let's say we have 5 sine inverse of x minus 2 pi outside of that parentheses is equal to 2 sine inverse of x, and then outside of that is minus 3 pi. So solving for this, we want to get all terms with x on one side. We want to get all terms without x on the other side. So let's subtract 2 sine inverse of x on both sides. And let's move that 2 pi on the left over to the right. So let's add 2 pi to both sides. So doing that, we get 5 sine inverse of x minus 2 sine inverse of x gives us a 3 sine inverse of x is equal to a negative 3 pi plus a 2 pi is a negative 1 pi, or negative pi. We can divide both sides by 3 to get sine inverse by itself. So we get sine inverse of x is equal to negative pi thirds. So we can think of it as taking the sine of both sides if we want. So sine of sine inverse, that cancels each other out, leaving you with the argument x is equal to sine of negative pi thirds. So I know my angle is falling in the 4th quadrant. Sine is negative. Or I can think of sine as being an odd function, and I pull the negative out front. And then sine of positive pi thirds Well, that is 60 degrees. And so sine is the negative, that would be root 3 over 2. So x is negative root 3 over 2 is our solution. Okay, so that is actually 8.1. 8.2 goes over the other trigonometric functions and their inverses. So this is inverse trig functions. Still continued. So I'm just going to kind of give them to you. So if you have y is equal to secant inverse of x, if and only if sine of y, I'm sorry, secant of y is equal to x. Okay, they just have it backwards. Where the absolute value of x has to be bigger than or equal to 1. And so secant is 1 over cosine. And so I remember to limit my domain between 0 and pi. We have to be careful here because there is a value where cosine, 1 over cosine, cosine is 0. Cosine is 0 at pi half, so y cannot be pi halves. If you're thinking of cosecant inverse of x, this is if and only if. Well, if we took this cosecant of both sides, the cosecant of y is equal to x. So where the absolute value of x is greater than or equal to 1. And that was because when we looked at our range for secant and cosecant, those were for negative infinity to negative 1. And then it jumped, and then it was from positive 1 to infinity. So writing the absolute value around that considers both of those. And then for this is like 1 over sine, and so this we're going to sandwich in between negative pi halves and pi halves. And so our y value is negative pi halves is less than or equal to y is less than or equal to pi halves. But we have to be careful because there is a place where cosecant is undefined between there. So that's when sine is 0 and sine is 0 when x is 0. So, or in this case, y cannot be 0. And then looking at tangent inverse, not a tangent, cotangent. So y equals cotangent inverse of x if and only if, take the cotangent of both sides, cotangent of y is equal to x. Well, the range of cotangent, that was negative infinity to infinity. So that's our domain of cotangent inverse. So where x is between negative infinity and infinity. And our range, it's between, well, this is, cotangent is over sine, cotangent. I'm just going to give it to you. It's between 0 and pi. which makes sense because if you looked at cotangent, one of those periods were sandwiched between the asymptotes of 0 and pi. So part of the last, I guess I missed it, but part of some of the problems in the homework is going to be using the calculator, and you should have a sine inverse, cosine inverse, and tan inverse on your calculator. Most calculators don't have, and that could be different nowadays, the secant inverse, cosecant inverse, and cotangent inverse, but we can always convert them to get the other. So let's see, how can we do this? Let me just show you one. So let's say it said cosecant inverse of root 2 over root 2. Okay, so let's make this equal to y. Let's for a second take the cosecant of both sides. So if I took cosecant, it's not writing. So that would just give us the root 2. This is equal to cosecant of y. Let's rewrite cosecant in terms of the trigonometric functions that we do know. And cosecant is the 1 over sine. And so we can rewrite this as root 2 equals 1 over sine of y. Let's isolate sine of y. So we could multiply both sides by sine of y. If we did that, we get root 2 times sine of y equals 1. So let's get sine of y by itself. So let's divide by both sides by root 2. So sine of y equals root 2 over 2. Sorry. It's equal to 1 over root 2. I'm trying to rationalize my denominator. Too fast. Okay. So rationalize our denominator. Sine of y is root 2 all over 2. Okay, so we're thinking backwards. What value of sine would give us back root 2 over 2? And that would have to be it has to be between negative pi halves and pi halves, so this would be pi fourths. So if these are ones that we should, we can always turn in terms of sine or cosine. I think is helpful. So what if it said secant of negative 2, secant inverse. So find the exact value of each expression. So you should be able to do this without a calculator. And so we can say this is equal to y. We're trying to figure out what y is. We can rewrite this in terms of sine or cosine, but let's first take the secant of both sides. So if I take the secant of secant inverse, that cancels each other out and will just leave me with 2. But if I do something on one side, I got to do it to the other side of the equation. So we get 2 is equal to secant of y.
Wouldn't it be -2?
Oops, thank you, -2. Drop my negative. -2. Divide both sides, or secant of y, but secant of y is the same thing. Let's now rewrite it in terms of sine or cosine. Secant is 1 over cosine of y. So let's multiply both sides by cosine of y. We get -2 cosine of y equals 1. Let's divide both sides by -2. We're looking at when is cosine of y equal to -1/2. Y has to be between 0 and pi for cosine. Okay, so I know that I'm in my second quadrant. I'm between pi halves and pi to get cosine negative. I would kind of first think about what my reference angle is by thinking of it, what cosine value gives me +1/2. So that's 60 degrees or pi thirds. So I know pi thirds is my reference angles. In quadrant 2. So to get that number or value, pi minus pi thirds would get me to that. So I have a 3 pi thirds minus 1 pi thirds is a 2 pi thirds. So cosine of y, so y would equal 2 pi thirds. So find the exact value of, let's say, tangent of sine inverse of -1/2. So first thing, we want to look at the inner function, sine inverse of -1/2. So we know that that value has to lie between -pi halves and pi halves. So sine of 30 degrees or pi 6 gives us +1/2. So we're going to have to subtract pi 6 from 0. So this gives us tangent of -pi 6. So tangent of -pi 6, that's 30 degrees. So that's going to have all the √3s and all the 3's in there. So √3/3. But we have to determine, is it positive or negative? And tangent is in terms of sine and cosine. One's negative, one's positive. So positive or negative divided by positive is negative. So it should be -√3/3. So let's do one more. Cotangent of cosine inverse of -√3/3. So we first want to look at cosine inverse of -√3/3. So I know that that's going to be between -pi halves and pi, positive pi halves and pi, because cosine is between 0 and pi for the inverse function. Think about √3/3, cosine of √3/3. That's not one we know. I'm just wondering if this is, something's wrong here. Well, I think this would be a great place to pick up tomorrow. So maybe let's stop there. Actually, before we stop there, I did want to come back to one thing I said I'd look at during break, which was that phase shift. And I can kind of explain to you why it is the way it is. We were looking at the phase shift of sine or cosine and looking at the value in between. So it works for both of them. Let's just look at sine. This is how we were writing it, a sine of bx plus c. So think about it this way. If we factor out a b from both of these terms inside of our argument, pull the b out here, that would leave you with an x term for the first term. But in order to get this to be c, when we distribute that b, that would be the same thing as c over b. If you're thinking about transformations, this is transforming it, like we were saying, was the opposite. So the phase shift here is negative c over b. If you were thinking of it with a minus sign though, maybe we can try that with cosine. If it, let's say it was y is equal to a cosine of some value bx minus c. If we factor out that b inside the argument, we would left with x minus c over b. So this is a phase shift, it has the minus, so it's actually a phase shift opposite when it's inside. This is a phase shift of c over b. So you can get the phase shift by looking at it this way and doing it. So don't think of it, like I said, I thought of it as absolute value, and this is where we're going left or right. And this basically tells you if you're going left or right from your original trig function. So hopefully that clears that piece up. Then